Seems like we got a new projector. Does it look the same before? Seems like the color a bit different. More vivid. Okay, we are really close to the end of the semester already. I'll post some review questions you could try, or you can try the exercises in the textbooks. And if so, if we finish earlier, then maybe the last lecture we will do some revision. Okay. So hopefully you're working on your projects. Yeah. So 3 minutes, around 3 minutes per person. Okay. So today, later on, we will discuss quiz 3 before finish, and so that you know what's this can do. But overall, I think quiz 3 are better. Is it because of the question are more straightforward, or what do you think? Purity. Okay. Okay. Straightforward. Easier answer. Easy to understand the question. Okay. Good. Okay. So let's continue from last time. So last time we were studying the arc length. Okay, so basically you have a function that draw a curve, and we try to approximate them using these straight line, a little straight line here. Okay, so this gives us a formula. Okay, formula actually depend on the dy dx, right? Because we label this small line here, small straight line here, approximated by some right angle triangle that can be written as dx and dy. Dx in width, dy in height. Okay. So we got this formula here. So integrate from a to b of these bigger ruler. Okay. So far so good. Okay. So next we will again do this ruler business, but this time we will look at function in the other way, right? So if you look at this curve here, right, this is actually not a function, okay, because it fails the vertical line test, okay, not function in x, but a function in y. Okay, so meaning you can place your ruler on the other way. Okay, so in this case here, instead of integrating along x, we could integrate along y for now. Okay, but doing that, you will swap your variable. Okay, so this is a bit like your quiz 3 question, right? In class, we ask you to do cylinder or washer along x axis, but the quiz one is along the y axis. And so we turn it around. Okay, so let's look at some examples here. So let's find the length of the arc of parabola. y square equals to x from 0, 0 to 1, 1, 1, 1. Okay. Okay, so we're gonna use the arc length that compute along the y-axis. Okay, so to get this, let x equals to y square, right? And then dx dy equals to 2y. And we're trying to integrate the length to be integrating from 0 to 1 square root 1 plus 2y squared, and then dy. Okay. Well, so this is a sum of 2 square here, right? Sum of 2 square. So perhaps we can use our trigo integration. Okay. So the trigo integration we will use here is actually tangent theta equals to 2y. Right. So how this integration is done again? So when y equals to 1, y equals to 0, what do you get? Tangent inverse 2, and then 0, y equals to tangent inverse 0, which is 0. Well, what is dy? Anyone remember what's dy? What's dy? Secant theta, tangent theta, is it? Maybe let's check. You can do the quotient rule. You can do quotient rule now. Maybe I can try and check whether it's correct or not. Single substitution. Oh, it's not written here. Do we compute out? Secant square theta. Yeah. Two times. Okay, is it correct? Differentiate tangent theta. Is the screen a little bit too bright? No, a bit bright. Huh? You want to turn on the light, or is it okay? You want to turn on the light? No, now it's okay. Because it's a bit too bright for my eyes. Okay. Okay, so integrating from 0 to tangent inverse theta, that's square root of square theta, half of secant square theta. Okay, and then from 0 to tangent inverse theta of secant theta, right? Cos 1 plus tangent square theta equals to secant square theta. Like that. Secant cube theta. Did we do this kind of integral before? Secant cube. Seems like we do it before. Let's check. Secant cube. Oh, we only did for sine to the end. Oh, we never did it before. And then shall we do it? Then how to integrate secant cube? So if you're gonna use substitution, right? You substitute secant theta, then what's the derivative of secant theta? Huh? Secant theta, tangent theta? What's the derivative of secant theta? Okay, I think we got time. Maybe we just do it. So what's the derivative of secant theta? Maybe we can try and compute. Hmm? Yeah. Secant theta, tangent theta. Okay, so you can see that there's no tangent theta appearing here. So substitution might not work yet. Okay, so well, what you can do was if substitution rule doesn't work, you will use the trigger identity first. Okay, so make it like 1 plus tangent square theta, for example, like that. Okay, then it will become secant theta plus tangent square theta secant. Okay, but I think we integrate secant theta before. Okay, this term we know, but how about the next term here? Okay, this is 2, right? Tangent inverse 2, huh? This is a scalar, not variable. Otherwise, it will be very difficult. So the next term here, there's a tangent theta, secant theta here. Okay. Well, hey, wait, let me check something. Okay, good. Okay, and then so for the first term here, we know what is it. This one we compute before. So integral of secant theta d theta is quite hard. So I think it's in example. Can't remember in which example. It is in this form. Secant theta. Ln of secant theta plus tangent theta. Okay, how about the second one? So tangent and secant appears together now. What can we do? Substitute what? Substitute tangent? Okay, let's try. So if you substitute tangent, okay, so what do you get? So the derivative of tangent is secant square theta. Okay? Ah, does it work? Feel like not working. So what should we do here? Hmm? Well, I mean like how about so what's this actually? Tangent square cos secant here. So it is like sine square theta over cos to the cube theta, right? Okay. So from here, is it better to see what to substitute? Ah, cosine. Cosine better. Yeah, let's try. So if we do u equals to cosine theta, du equals to uh, minus sine theta, we still got one sine left over. Now what should we do then? What if you substitute sine? What do you get? It's supposed to be so tedious. Let me just check. Yeah, I think so far correct. Yeah, so far I think still works. Okay, I think the problem is this tangent square theta secant theta here. Well, let's see. Do we have some technique from last time? Let's see. Let's check. Creation. Yeah, so this technique says what? If the secant is even, save it. The tangent is odd to save. Okay, so let's see what is our case. If the secant is even, so our secant is odd. If the power of tangent is odd, our tangent is even. Useless all this. Okay. No wonder we are stuck. It's very useless. Okay. So let's see. What should we do here? Let's try. Never mind. Let's try first. See how. So d theta. So this will make it into u square du minus over cos to the 4 d theta. Okay. But I think cos to the 4 theta here, we can make it into u again, right? Because cos square theta equals to 1 minus u square. Okay, this one okay or not? Like this. So, okay, let me write down everything. So, integrating tangent square theta secant theta d theta becomes this. Integrating of this of du, which is equal to this. Okay, what do you mean? Why cannot? Can't we use partial fraction? Can't we use partial fraction here? This will become 1 minus u square times 1 minus 1 plus u square. That's true. Because 1 minus u square is 1 plus u times 1 minus u, but you have 2 times. Okay, so but is it so complicated, this question here? Should we continue? So this is a repeated root, right? Repeated root. So we should be able to write u square over 1 minus u square times 1 plus u square to be a over 1 minus u plus b over 1 minus u square plus c over 1 plus u plus c over 1 plus u. Okay, right. So let's do some substitution. B times 4, so u1 is 1 square. Okay, and then when u equals to minus 1, minus 1 square equals to d times 1 minus minus 1, 2. So d will become 1 over 4 as well. Okay, so we need to figure out what is c and d, a and c. What value we can try? Try 0. 0 is easy. So 0 becomes a times 1 times 1 plus 1 over 4 times 1 plus c plus 1 over 4. Right, so a plus c becomes minus half. Huh? Okay. Okay. Uh, should we get the next one? Or can we just substitute in? What's the next easiest number? 2. So let's try 2. Equal to 2. We got 4. A is minus 1. 2 plus 1 cube 9 plus B 3 9 C minus 1 square become 1. So 2 plus 1, 3, 3 plus 1 over 4 times minus 1 square. So it becomes 1 again. Okay, so you got this. Hey, what is our B? B is 1 over 4, so we can put it in. Okay, so there's a 1 over 4 appearing, right? So maybe we can make the denominator the same. So push everything away. 16 plus minus 9a plus 9 plus 3, so plus 12c plus 1. So what do we get? 16 minus 9, 7, 7 minus 1, 6. 6 equals to minus 9a plus 12c. So divide everything by minus 3. So 3a minus 4c equals to negative 2, right? Divide by minus 3. Okay. So we got these two system of linear equation. So one of it is this. The other one is 2a plus 2c equals to minus 1. Okay. I think I prefer to solve it like this instead of substitution. Can we try? Let's try this. So row reduction. 3 minus 4 minus 2. And then how about in that case, never mind. Since they are not aligned. Okay, no, they're aligned. So should so let's do which first? I feel like doing yeah, never mind. Let's do step by step. So I need to make 3 a pivot. So I do 3 times row 2 minus 2 times row 1. So this one I got 0. 6 plus 8. 6 plus 8 is what? 14. And then minus 3 plus 4 become 1. Okay, and then is it correct? Let's check out. Okay, and then continue. So I need to make the number above 14 0 to make it a pivot. So I take row 2 plus 7 over 2 row 1. Correct. Here I get 21 to row 1. Here I get 0. Sorry. Wait, so wait, let me see. So here is row 1, here is row 2. Okay. Here's 3, here's 0. And then minus 2 7 over 2. What do you get? 3 over 2. Okay, so in the end you get 1 0 1 over 2. And then this one you get 1 over 4. Okay, so A equals to 1 over 2, and then C equals to 1 over 4. Is it so complicated? I'm doubting. Okay, let's try right down first. Maybe someone can use the online calculator to check whether this is correct or not. Someone want to use online calculator to check, is this really hard integral? And then is this partial fraction correct or not? Maybe you can use online calculator and check if the calculation here correct or not. Okay, Jing Jie, you think? You didn't use this method? What method you use? What method you use? Yeah, yeah, good. Oh, you mean use part? Or you mean by part? Let me see. You, you mean use by part? Oh, okay, makes sense. Okay. Okay, so maybe someone can continue this. Seems like a bit long here. Okay, you can try and continue this. So let's try a Jingjie method. So let's come back here again. Come back to the secant square theta again. Someone can try and compute this, see whether you got the same solution or not. Okay, you can continue this. But let's try a Jingjie method. Okay, let's try this. So let's try method 2. Okay, so he says that we're gonna split this into two part here. Okay, we still use the observation just now. So what which we know that uh, d over dx of tangent theta equals to secant square theta. Is it this one? Is this one? Okay. So he trying to use by part, right? So by part meaning you need to set u equals to secant theta, and then v prime is to equal to secant square theta. Okay. And then what? And then using by part. So what is okay? So let me write down what's the by part here. Then what's the derivative of u? Secant theta. Just now I think is it Hisham? Did you say that this is secant theta, tangent theta? Okay. And then v prime, what is v prime? So after integrate v goes from this this derivative here, we got that v is tangent theta. Okay, let's see if this works or not. So uv integrate negative integrate v du. Yeah. Is this what you get, Jing? Is this far from what we get just now? And we also have this term. Oh. So how do you settle this tangent square secant theta? How do you settle the second term? We have the same thing up to here. Let's see how you can be. We got the same term. Oh, you reproduce it. Oh, did I not realizing that? Let me see. Did I not realizing I reproduced it already? Ah, right. Right. Oh, okay. So instead you evaluate this guy here. So he so you see up to now we are the same, right? Are we the same? Not quite the same. You have some extra thing. Oh, I haven't do this yet. Okay, I got okay. So you say that you reproduce it. This will get like this. Plus one or minus one. Let's try. Minus one. So let me write down first. Okay. So here is sine square theta equals to cos square. So I think it's one. Okay, should be minus. So here should be minus. Okay. So should be minus. So this is minus. So this will become secant cube theta secant. Okay. So you can see that this term appear again, right? You can see, yeah, okay. So then we can group these two terms together. Then we left with secant theta tangent theta plus the integral of secant theta. Okay, so I think this term we have produced it already. This term here, but this term and that term we haven't produced. So I think that's the thing that you will compute from the partial fraction just now. Okay, so this will give us that integrating secant cube theta d theta is half of secant theta tangent theta plus the integral of theta. Okay, such a long thing. Okay, yeah, I think we should plug this back. Then this length here will be equals to half integral from 0 to tangent negative 2 theta d theta equals to half and half plus secant theta tangent theta evaluate from 0 to tangent equals 2. And then this integral here, just now we say that this is ln of secant theta plus tangent theta. Then it's from 0 to tangent 2. Okay? Yeah, I think quite complicated length here. So here, what do we get? Secant of tangent equals 2 times everything times 2 plus tangent inverse, you get entity. And then tangent 0 is 0, so we don't care. On the other side, we get ln of secant tangent equals 2 plus 2 minus ln 1. So minus tangent 0 is 0, secant 0 is 1 over 1, so ln 1 is 0. So you get these two terms. Yeah, this is the length. Now we check using online calculator. Let's check. Zero, two, one. Okay, so let's try this one directly. So I didn't type anything wrong, right? S- Integrate from 0 to 1 and then square root 1 plus 4y squared. Okay, let's try. So we have the right form. Okay, so seems like this answer could be easier. Square root 5. Let's see, can we get to square root 5 or not? Tangent inverse 2. Let's see. Okay, so okay, let's before calculating, let's see what step they give us. Are we matching them or not? Do we have this? They also use trigo substitution first. Secant cube 1 over 2, 0 to tangent inverse 2. Okay, we are on the same step. And then what they do, what is apply integral reduction? What's this? Oh, you have to pay. Okay, okay, well, sure. So the point here is they can get this square root 5, or are we getting the square root 5? Let's see. This term is square root 2 plus square root 5. So can we get that? So meaning if you go back here, we got the 2 already, right? So it means that this term is a square root 5. How to see it? We press calculator. You have calculator? Let's see. Tangent inverse 2. Okay, so the closed form is here, I guess. Second of tangent inverse square root 2 is square root 5 over 2. If it is square root over 2, let me see. Hey, square root 5 over 2, why is it just 2 then? You need to use this method to help you calculate if you want to get this number here. Okay, okay. So you basically use this number here, right? And then you know that tangent theta is 2. So you plug your 2 here, then your secant square theta is 5. So your secant theta have to be plus minus square root 5. Then why is it over 2 here? Why not just plus minus square root 5? Hey, you see, this is a scam. You see a scam here? It says that this is square root 5 over 2, right? The method calculate is just square root 5. So which one you believe? What you believe? So I present a scam here. So which one you want to believe? Obviously, you need to look for the method. Okay, so the method here looks very convincing, right? You just use this trigo identity. Okay, but we know that tangent theta is 2. Okay, so we put the 2 here. So this means that secant square theta is 5. But where you get this theta from? This theta actually is the tangent inverse of 2. Okay, so actually it's just square root 5. I'm not sure why the first line is square root 5 over 2. Should be square root 5. Yeah. Okay, I mean, like, obviously you need to make a decision, otherwise either it's positive or negative. Okay, but since our tangent inverse live in this region here, your secant should be take the positive one. Okay, so if we replace this by square root 5, what do we get? Let's see. Okay, is this close to the solution? Let's see. Is this close to the online calculation? So the last one is this. Half times square root 5 times half times this. Okay, so look at here. Look at ours. So 1 over 4 cancel with 2, you get. Okay, so meaning you take a 1 over 2 out of 1 over 4, multiply by 1, multiply by 2, you get 1. Multiply this by half, you left in a half. So we get the same answer. Okay, so far. Is it okay? Or should I write? So here we multiply in the half. So we get the same answer. So not secant tangent equals 2 equals to square. Okay. Yeah. Any questions so far? Uh, I suggest you use another way to compute. Can you use the horizontal ruler to compute? So meaning you need to figure out what's your y. Okay, take y to be square root x. Okay, and then do integration from 0 to 1 again. Okay, on square root 1 plus dy dx. So here the dy dx will be 1 over 2 x to the 1 over 2 over square root 2 like that. Okay, so you square this. Okay, try and compute this. This should give you the same answer as well. So in turn, this is integrating from 0 to 1 again. Then this is 1 over 4x dx. Awesome. Yeah. Is this even harder to compute? Is this even harder to compute? Let's try the online calculator. So let's see. Yeah, should get the same answer, but where you start here? By parts. So you could go by part. Seems like this one is easier, although it looks very daunting, but you just use by part instead of three-go substitution. Yeah. But anyway, both way will give you quite a tedious calculation to do. So you could try a very good exercise. If you can do this whole question, I think you are mastering the integration. Yeah. So if you use both way, one way you use trig, the other way you use by part, then you learn everything in the chapter already. Yeah. Try and compute using these two ways. Okay. Any questions so far? Didn't realize that this question is so hard because I prepare a wrong question. So we need to work out. So if someone there enough, maybe can continue with this partial fraction. Yeah. Okay. Right. I think we need to keep all these in the lecture, not later. Right. So the last part before we end, right? Let's do this. So we can compute. Uh, so just now we compute an arc length, right? So meaning, I give you a finite distance. I ask you compute what's the length of your curve. Okay, but we can, because you can do this for every finite interval. So meaning we can make it a function as well. Okay, we can make it a function. So meaning instead of integrating from a to b, right, we just integrate from a to some x. Okay, depend on what x you want. Okay, instead of b here, we put an x here. Okay, so this is the difference. So it become a function. Okay, instead of finite length, this length here will depend on how far you want to integrate. How far you want to integrate. Okay, I guess this one is easier. So you see the formula is the same. Okay, it's still square root 1 plus dy over dx square. But here, this x here will depend on your what b you take. Will you guys confused if you look at this? Because just now we write 1 plus f prime x dx, right? But now this x is like replacing the x direction. Okay, so we change the x inside your function become t. Okay, so this is, you can think of this x is a moving b. Okay, the b is moving. Depend on what b you want. Okay, depend on what b you want. So it's really the same thing. It's just making it into a function. So if you like, we can compute dy dx to be 2x minus 8x. In this case here, for this curve, is it straightforward? Derivative. Differentiate x squared, you get 2x. Differentiate ln x, you get 1 over x. And then your function will become, your arc length function will become x sx. Integrate from 1 to x because you are starting from 1, 1. And then square root of 1 plus. So we replace the x before become t, just so that we know that x is not equal to t. These are different variables. So x is representing the moving endpoint b. Okay, we don't know what b we want to stop. Okay, so we make it a variable. Okay, so t is another variable for your curve. Then you just do this integration. Integration. Something like this. dt. Okay. And then what's next? And then you realize that you can factorize this. Okay. Is it true? Let's check. So this term square to this, and then this term square to this, and then that two multiplied together is 1 over 4. 1 over 4 plus 1 over 4 is 1 over 2. Okay, so 1 minus 1 over 2, you get 1 over 2. Okay, so actually you are integrating 2t plus 1 over 8. Okay, so this will become easy. And then you just get x squared. Okay. Did you realize something weird happening here? Did you realize something weird happening? After you integrate, right, you get back your curve. You realize after you integrate it, you get back your curve function. It's the same one. X squared minus 1 over f of x. T squared, oh, a bit different. Slightly different. Okay. Yeah. Okay. Yeah. So far, any question? Yeah. So that's why you learn all these integration method, trivial substitution. Actually, what you learn is to serve for this kind of purpose. They are trying to compute the length of some curve, and then you involve some integration technique. Okay. Any question? Any question so far? Any question? No. Okay. If no question, let's take a break. Let's break until 10, 12. Oh. Hmm.这个写出怎么说呢？嗯，对你呀，什么？这个是从这边到这边。对，没错没错。他算有这个这个没办法强调有多了一个三元，多了一个 cos 元，好像消不掉。怎么说呢？因为这个是 sin square theta 嘛，这样我这个一个对一个然后你就你的 cos 过来，对 cos 过来变4个嘛，变4个过后我就可以两个小，嗯这个这个这个是 d theta 除以这个是乘3对呀、因为 d theta 等于这个除这个，然后我把 theta 变成这个，对吗？是的，就是 d 我们减 cos theta 等于 d theta。对，我们然后把这一个变成这个，所以这一个加上这一个加上这个，变然后
有个更简单，就是
更简单，
U等于 cos
u 等于 cos 平方 theta，然后 d 等于cos theta sin theta d theta 这样子，然后
这个一部分用这个，
我想一下，
就是 sin 西塔，电西塔用这个，那 cos 一个对面去。
看一下，嗯，说已经说这样的话就变成 sin square theta cos theta u 这样，然后你说这个
这个部分
一部分，我看一下来
sin 西塔先留问，
cos 这样这样，
那你 cos 抽过来这边又同样的平，
你是说 OK
只有替换掉
呀呀，所以这边变，
cos 西塔，
然后这边就变成对，没有错，
sin 西塔的，然后这个是 U，
对，没有错。
然后 sin 西塔等于减去法，减掉是肯定好。
哦，是这个意思，应该也可以，可以，那个应该可以，这个一减。可是你这样子做哦，你这样子做，这个好 integrate 吗？
以后放进去了，
可是你的，
放在根里面，
可是你放到根号里面，这个容易 integrate 吗？这个你做得到？
这个
这个感觉，这个感觉，这个难度应该是跟这个会不会一样？好像比这个还难一点。这个，因为这个是一加一 over 什么东西？这个就有两个都有一 over 的，还是你要用白盘呢？会不会可能你要用白盘？就是白盘这，
有撇
就是这一个跟这一个盘。
不担心，
嗯，不担心，
是看不出来这个。
不然这个更惨吧？这个，
嗯，
你说成功了啊
没有，
哦，你就停在这里。感觉这个蛮难的，这个。
这个算出来。
对呀、这里的话还有一点点可能，这个就
嗯，T 把它换掉，
可以把它换掉。嗯，
还不行，还要倒一个，
你说把这个里面换掉，
先要倒，
下面的，
过来。
嗯，你可以再试试看，你再试试看。
上面那个就可以，
对呀，对。OK，雅婷 here 呢？和雅婷，OK，陈凡呀，吴雨夜，吴雨夜了，OK，洪亮，洪亮，OK。Have you guys decided your leader? Who's your leader? Oh, you one person. 嗯，西河，Have you guys decided your leader yet? Sorry, you are alone also. Okay. 乐天，your leader decide. Who's your leader? 啊？什么？什么？You haven't? Please now decide now. Where are you? Who are the member? Decide now. Gonna submit soon. Eh? Who's your leader? Decide now. After I take attendance, I will come back to you again. 瑞阳呢？OK，瑞阳的 leader decide 了是弱势，OK，弱势，and then 斯曼，OK，嗯，一男，嗯，玉涛，陈玉涛，OK，玉涛，your leader decide already？ Who is your leader？所以叫什么名？10，对，OK，fix 了。一泽，OK，一泽是16那个 fix already。丽文，丽文 got just now come here. Hey, group 4 the topics haven't fixed group 4. So Yu Tao, your guys already fixed your topics? Yu Tao, first topic. Ah, not yet. How? You haven't start discuss how? Only 2 weeks left. Huh? So how? How to submit? This weekend, okay. Otherwise, no time anymore. If you start late, then you will delay. Then I'm not sure you can send in time or not. Who is in group 4? Yu Tao, Yiling, Yiling. Yeah. Please make sure you have a topics. Okay. Okay, if you don't have the topics later, we will make one topics. Maybe you can see if you like or not. Okay. So next part is about surface area. Again, it's a revolution. But previously, we revolute a function or a curve along x-axis or y-axis using either the washer method or you use the cylinder shell to compute. Right? But those are computing the volume. So you are filling out the space. But now, you just look at the surface area. Okay, you just look at the surface area. You don't look at the entire space. Okay, you just look at the surface area. So you can see that, for example, the cone. Okay, if you revolute the linear line, you get a cone. Or if you revolute this curve here, okay, along x-axis, you get a vase actually. Okay, but we are not filling it in. Just surface area. Just look at the surface. Okay, so maybe you can think of vase here, an empty vase in particular. Okay, 空的花盆 an empty vase. Okay, previously we need to fill it in, so it's a volume. Okay, now it's just a surface. So what's the formula then? Okay, so the formula is 2 pi times the so let's look at this direction first. Okay, let's look at this direction first. So look at this direction. So we revolute around here, x-axis. So this formula will be 2 pi of yx. So this yx here will become your radius. Okay. And then multiply by this part here, square root of 1 plus dy dx squared. Can you recognize this part? Square root of 1 plus dy over dx squared. What's this part here? What's this part? Can you recognize? We just did it right just now. We just did it right. Integrate a to b square root 1 plus dy over dx squared dx. That's the length. Yeah, that's the length. Okay. So meaning you compute this circumference and then multiply by the length. Okay. Make sense or not? Does it make sense? Yeah. Okay. So you take 2 pi r. Okay. So this is the rate circumference of your surface of revolution, and then you compute how many square you computed. Okay, how many circles, sorry, how many circle you have computed. Okay, so you multiply by the length. Okay, does that make sense? Yeah. Okay, so on the other hand, you can change direction. Okay, you can also change direction. Let's say your curve is again y equals to fx. Okay, so let's say it's the same curve actually here, but instead you will revolute in the y axis, around y axis. Okay, so you can see that it's something like this. Okay, then is this what it is trying to say? Let's see. Rotating the curve y equals to fx when x going to be, yeah, sure. Okay, so your radius here is just x because you are going from A to B only. But you can see that um, what happened here was this radius actually is not straight. Okay, so that's why there's a dx component coming out here. Okay, or not? So the difference here is if you revolute around x-axis, then the height of your function, okay, fx become your radius. And if you revolute along x-axis, y-axis, then your x is just x itself. Okay, but there's some curve going on here, so you need to multiply by this contribution of dx. Yeah. Okay, maybe let's look at one of the shape here. Let's look at one of the shape here. This shape from the textbook maybe will make more sense. Okay, let's look at this picture here. Okay. Okay, maybe this picture will make more sense. So if you revolute around x-axis, so you are taking 2 pi r radius and the height. Okay, so 2 pi r times height is what? It's actually the surface area of a cylinder. Okay, so you should think about it like this. So this is r radius, this is height. Okay, but you can think of your cylinder is like irregular. Okay, so that's why this height here is like get squished and become dx. Okay, so how about rotating around y-axis here? Where's your radius? So your radius is just x, and then multiply by your height is dx. Okay. Okay. Any question? No question? Okay, if no question, let's try some question here. Let's try some question. Okay, find the area of the surface revolution. So in the exam, please read carefully whether you want to find the area or you want to find the volume. Okay, so this will be area of the surface. Okay, surface only got area. Sometimes in the volume, what do they call it? Solid, right? Solid of resolution. Okay, so you need to fill in the solid. But here is surface of revolution generated by revolving the curve y equals to square root 4 minus x squared. Okay, so how to draw this graph here? How does this graph looks like? Well, in the quiz, I only see one of you drawing the solid. If you are not drawing the solid, how do you know how you're gonna compute? You guys just guess which function minus which function. Because no one draw in the quiz tree. I think only one of you draw. How do you know which one minus which if you don't draw? Very dangerous, if you just guess. Okay, so what's this graph here? Well, this is part of a circle, right? Square root 4 minus x squared here. Did you realize? So this one will satisfy like x squared plus y squared equals to 4. And then y equals to square root 4 minus x squared. Okay, so it's a upper half plane part of your circle with radius 2. Okay, maybe it looks something like this. Okay. And you want to find the area of surface that revolution by revolving this curve about x-axis. So you want to turn this on. Okay, can you imagine what this object looks like? So you go around like that. Can you imagine what is it? Imagine. It is like a tire. It's like a tire. Okay. Okay, it's like a tire. Okay, so it looks like a tire here. Okay, so you want to find this surface here. Well, to find this surface, what's our formula? Write down our formula first. So we need to integrate from a to b of 2 pi. 2 pi is necessarily there, but you are integrate along x-axis or y-axis. So x-axis. So for x-axis, your radius will be described by your function. Okay, if you rotate around y-axis, your radius will just described by your x. Okay, so you need to put fx here and then square root 1 plus, maybe put yx here, plus 1 plus dy yes, square dx. Okay, so what's your AB? Okay, so our AB is minus 1 to 1, and our yx is square root 4 minus x squared. So you need to figure out what's the derivative. Okay. Is it easy to compute? Can you quickly see this is minus x over square root 4 minus x squared? You use chain rule, and then this everything squared. Okay, so this will become 2 pi from negative 1 to 1 of square root 4 minus x squared times square root 4 minus x squared plus x squared over 4 minus x squared. Yes. Okay. And then this is just minus 1 to 1 square root 4 minus x squared. 2 over square root of 4 minus x squared dx. Okay, so this will become some very easy integral. Okay, you can check my solution, okay or not? Make sense? This conversion. Okay. Do you feel like this number has no meaning to you? Do you feel no meaning? Huh? Any meaning or not? At pi? At least not for me. If you change different thing, I don't know what's this number gonna bring to me. But I mean, the most important point is, I guess, um, the way to figure out this surface area here. So what's the radius? What's the height you need to consider? And why are we looking at this formula? I think this is the more important thing. But this add pi is really like not very important. Whatever 16 pi or whatever pi, it's not very important. Okay, the important thing is you need to realize what's the radius you use, what's the height you use. I think that's the most important thing. Okay, do you want to try this? F point 7, can try this? I'll let you try first. Maybe I'll check with your final answer, see we have the right, we have the same answer. Maybe I give you about 5 minutes. I can take my attendance first. 瑞妍 here, right? 瑞妍 good. 瑞妍 fixed already. Zehan, is Zehan here now? Zehan. Zehan, have you guys fixed your topic? Yeah. Did I write it down? Our topic 4. Okay, good. 嘉来, yeah, got. 嘉来, you are alone? Which one? Can. Can. Oh, the can, shape of a can. Okay. 嘉诚, 嘉诚, you guys fix your topic? What is it? Haven't told me yet. Cylinder? Cylinder. Which cylinder? Nothing more. 啊，什么忘记了？后来你不是讲
觉得那个公交车等公交车时间
那个不是多维啦，是一维还是多维？
对那个 normal distribution 做那个 derivative，
是一维的吗？
正态分不是几维的，
问你，但是你是不是说你要回去再看一看？是你忘记了？
对，
哦，你就说那个
就是那个对，
，OK，说等公交车，我想一下叫什么来着？Waiting time，bus waiting time，OK，确定是一维啊？你确定是就是来 function of one variable，OK，那确定一下是一维啊。So 你们两个 who's your leader? Me, you, OK。嘉怡，and then 齐军. 齐军, you guys got your question already? Topic? 啊？什么 Have you guys fixed your topics yet? Your presentation topics? What's your topic? Group 9. Yeah? Yeah, what's your topic? What's your topic? Your topic 是什么？
我不太清楚他这个是
你不太清楚 topic 什么？Where's your group member 啊？俊杰啊，新阳啊？What's your topic? Sure. You don't want to choose, you have to give me one. But need to be a function of one variable. Meaning like fx, oh? It's not like fxy like that.
我看出一个
Law of gravitation. So what are you guys doing there? But make sure that you are using one variable, a function of one variable. Don't go several variable because that will be calculus 2. You will try? Okay. 你去问一下你的助理。Who's your leader? You are 俊杰啊。You are your leader. 找谁？谁是他？刘新阳，you will be a leader. Yeah. Yeah, please don't use two variable, that will be calculus 2. More than one. Just do one direction enough. Okay, so let's see how do we compute this, the arc length, the length of curve. So let's draw the curve first. Y equals to x squared like that. Okay. And then where's 1, 1 and 2, 4? Maybe somewhere here. 4. Rotate about x-axis. Okay, so you need to rotate this guy here about, sorry, y-axis. Okay, so it's in this direction. Okay, so in this case here, so you rotate about y-axis. So your radius is just your x. Okay, and then your dx will be still the same. So your formula would be area integrating from a to b of 2 pi x dx. So AB here is so it's still the dx direction, okay, from 1 to 2, 2 pi x, but here square root become 1 plus dy over dx. Okay, so what's this here? This is just 2x, right? Yeah. Okay, so you get 2 pi of 1 over 2x square root 1 plus x for x squared dx. Okay. So just now we have a hard time to integrate square root 1 plus 4x squared, right? But now it's better because you have an x beside it. So what you can do? Substitution. Okay. So here you can do substitution. So you just substitute u equals to 1 plus 4x squared. Right? Just now we are having a very hard time because there's no x there. But now we got an x because the derivative of 1 plus 4x squared is 8x dx. Okay. Then so you do substitution. 2 pi, and then you need to change your integration limit here, right? So when x equals to 1, u will become 5. Yeah. When x equals to 2, u will become 17. Okay. So here's 5 to 17. And then square root u over a du. And that. Okay, then this will become very easy to integrate. Okay, so this will compute to something look very not as pleasant. Pi over 6 times 17 times square root 17 minus 5 square root 5. So a lot of radical coming up. Okay, right. So actually there's another method to compute this. Okay, instead of looking at y equals to fx, you can look at x in terms of y. Okay, so that you can use the first method to compute. Okay, you can try and turn it around and then use the first method to compute it. Okay, you should be able to get the similar solution here. Okay, so what do I mean by that? So instead of doing this integral, what you do is you consider the y direction. Okay, let's say because here is 1, here is 4, right? So you're going to integrate from 1 to 4. And then again is 2 pi x, but you will use square root of 1 plus dx over dy square. Okay, you can try and use this. You should be able to get the uh, same same calculation. So x here will become x equals to square root y. Okay, so you will use this x equals square root y instead. Okay, you should be able to compute to the same thing. Okay, and next part, okay, before that, do you have any question for this? Any question? Okay, if no question on this, next part we won't include in exam. So this is not examinable, but you can try and do this in your presentation. Like E-Link, E-Link, you haven't fixed your topics, right? Maybe you can consider this. Yeah, this is physics also. Uh, who is Jingjie, Jingjie. Yeah, this part is also physics. I think this is related to gravity, but this is the center of gravity. Yeah, center of mass. Yeah, this part I guess is very useful for physics, but I don't think it's quite useful for you. But you can have a look on how to find the center of gravity. Yeah, you know gravity? I thought you say you are doing gravity. Yeah, law of gravitation, Newton's law. Okay, from Kepler's law. Okay, sure. Not very related. No, it's physics, but maybe it's not this moment stuff. Hmm. Yeah, do I have anything to comment about this? Actually, not much. Not much. Oh, are you guys interested in this moment stuff? Not interested. Okay. I'm also not interested. But basically, okay, the idea of this is like when you like rotate this piece of paper, you rotate it around. So how could it stay on the point? Okay, so where's the center of mass? Okay, where's the center of the mass? So that it can stay on the point. Okay, so basically this is the idea. Okay. Maybe we just skip this. Yeah. Okay. Uh right. So I guess skipping this will finish section 8 for now. Yeah, any questions so far for section 8? Basically, there's two things you learn only. One is arc length, the other is surface area. That's it. Okay. Surface area of revolution. So for now, up to now, you already learned how to find length, how to find surface, how to find volume, the volume of a solid of revolution. And then to find this, you need to learn how to do trigger substitution, bypass substitution, rules, and then what else? Anything else I missed? I think pretty much. Oh, partial fraction. Okay, partial fraction. These are the things. Yeah. Yeah. Any question you want to ask? Any question that you want to ask? Or you want to ask? Oh, when's the quiz? So the last quiz will be happening on week 14. Last time, there are like 8 of you didn't submit. So it's a very kind of waste of chance. Okay, because quiz 3 is very easy according to your result. Because your result is very good. Whereas the mean without the 0 marks are 17 over 20. It's very high. So quite a lot of you get like 8, 9, 20 actually. I already give back to you, right? Did you see it on the Moodle? You can check your result. We're gonna discuss the result soon. Yeah, you can check your result. I already post to the Moodle. You can check. And anything I want to update you? Oh, midterm. So I guess by latest we will release your result next week, and then we will discuss in class on Friday as well. Because Friday we got more. Wednesday we only got 2 hours. Um, yeah, are you excited? You should be excited. Okay, so if you once you get your exam paper back, right, make sure you look at your solution where you make mistake and then try to don't do it again in your final. Yeah. Okay, if we have any miscalculation, you can let us know on the spot as well. But you cannot get your test paper back because the school need it. You can take photos, and we have scanned it as well, so you cannot take it back. Need to be returned to the school. Okay. Right. You guys want to finish class earlier? Sure. Sure. Okay, let me think first. Let me see how much we left first. So let's see if we can finish class earlier. Okay, so one thing we want to do before the class finish is quiz 3 discussion. And then let's see how much we left for last chapter. So the last chapter is differential equation. Okay, so you have a derivative. Okay, but the weird thing is your derivative is defined in terms of your function again. Although this is weird, this is easy for us to calculate actually. Okay, this is easy for us to calculate later. I'll tell you why, but I'll tell you why later. Okay, but then you will learn a few of differential equation. Okay, a few types. Okay, what I mean. You just see something weird here. df over dt is equal to something in terms of f again. Okay, this is the special part of differential equation. Right, your f pops up again in the derivative. This is actually not how to say, it's um, not that weird or not that surprise. You see this before. What is the derivative of x at e to the x? What is the derivative of exponential function? What's the derivative of e to the x? dx. So meaning what? Df over ds is equal to f. So meaning what? E to the x satisfying some differential equation, which is after differentiate, you get back yourself. So this one, after differentiate, you get back a deform of yourself. So kp times 1 minus p over n. Okay. Yeah. Okay. So we will study a variant of these. So just now your okay, let me write down. So just now your e to the x, right, will satisfy d to the e over x over dx equals to e to the x. So when k equals to 1. Okay. The next level is you multiply by a k. Okay, so multiply with k, you can see that I find a solution. You can see that the solution is not far from e to the x actually. So you multiply a k beside your x, not far from e to the x. And then next level you will study this kind of model. And then this model makes sense because it's related to this math spring system. Okay, and then you will learn something of this direction fields. I'm not sure is how useful is for CST, but we will view this derivative as some vector. Okay, some vector, and then this vector we can plot on every point. Then it become a field. Okay, can you imagine a field with this vector here? If you have free time, you go and walk around the field in front of your A3, right? Especially go during the windy days. Okay, so you go to the when during the windy day when the wind blow, you can see that the grass like move along the direction of the wind. Okay, so this is how you imagine this direction of field. Every point you got a vector, you got a direction. And when the wind blow, the grass like certain direction. Okay, and then we'll learn some approximation method here. And then why is it easy to compute is because of this separable equation. Okay, we will have some heck of integration integrating some derivative. This is a bit like the implicit differentiation, okay, where we differentiate everything across the equation. Now we integrate across the equation. But when can we do that? Okay, we need to group the variables together. And then there was something called the orthogonal trajectory. So given, let's say you're given a family of curve, can I figure out the curve that's orthogonal to this curve or not? So previously tangent line was tangent to this curve, but now can you find a curve that's orthogonal to this curve or not? Okay, so it's the other way around. So differential equation can help you to do this. Okay. And then there's some application problems here. And then one more model, one more model. Okay, this model is what we see at first, right? So this model can be used to model some population growth and then logistic model as well. And then we'll try and solve some logistic problem. So it's a bit like if you are rearing a den of chicken, right? Chicken, you rear a lot of chicken, right? So can you forever breed the chicken or not? I mean, like, can the chicken grow as many as they like or not? What do you think? Can they breed forever? Can you grow from like 10 chicken to 1,000 chicken? Can 100,000 chicken? Can or not? 10 million chicken? Can or not? So one thing you should think is, can it fix or not? Let's say I fix this room. Can all the chicken fix here? So it means that this number of chicken must met a limit. So what's that limit? So this is the problem that they're trying to figure out. They try to model using differential equation. And then I think this is the last thing, linear equation here. So I guess in this class, right, you will only learn the first order differential equation, which is linear. That's it. You will learn until this stage. So let me see. Yeah, you only will learn until this stage, first order linear. Obviously, you can imagine that there are second order linear. Yeah, second order meaning something need to go to second power, second order power, higher power. And then this is linear. So you should think that there's also non-linear case. Okay. Yeah. Actually, the non-linear case is what happened when you deal with the fluid dynamics, for example. Okay, those are non-linear. Okay. Have you heard about Navier-Stokes equation? No. It's a millennium prize in mathematics. So they are trying to find out a solution for non-linear differential equation. This is still ordinary, so meaning this is like one direction. Okay, they can consider more direction. Like in calculus 2, you will go to 2 variable, 3 variable. So those are what we call partial differential equation. But those are not important for you. Just let you know that there's something even harder is going on. So you are learning the first case. Okay. How about we take another break and then we'll come back for quiz 3 discussion. Then after that, we can be free. Okay, we'll continue with taking attendance first. Teaching, teaching. Okay, teaching already got question, right? Yeah. Jingyi, yeah. 相思, yes. 相思 got question already. Have you guys fixed the question yet? 谁是 leader 啊？相思 is leader. 相思 oh movie. Yeah, okay. 1010 figure out already? Still thinking. Question. Okay. 冰珍 yeah. 冰珍家谈浩云文琪 I think 文琪 got right. 文琪 right? Yeah. Hang Xiang, Hang Xiang, still doing football, football. Okay. Jing Jie, oh, Xing Ya, Wang Da, Wang Da, yeah. Xing Yue, Xing Yue got Yu Hen, Yi Tian, is that at the back? Bing Chen, Miao Bing Chen. Have you guys fixed your topic yet? Okay. Hey, who's your leader, Bing Chen? Oh, Margaret, huh? Margaret. Did I record it down? Oh, Margaret, huh? Okay. Margaret, huh? Okay, vote, 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 vote. Margaret. Yeah, you see? They vote you. Okay. Okay. 冰城 浩然 where's 浩然? 浩然, I think I saw you. Okay. You guys six already, right? 浩然. Oh, 浩然 is the one with Yu Tao. Yu Tao, Yu Tao, and then Yiling. Oh, you are guys in the same group. Okay, please listen. Desmond got. Is Desmond leaders fixed already? Who is your leader, Desmond? You are? Okay, good. Tommy got. Chong Yi got. Ying Jie, is Ying Jie here now? Ying Jie fixed already or not? Ying Jie, you guys fixed already? 13, group 13. You guys haven't fixed, Ying Jie? What's your topic? Huh? Don't know. Where's your group member? Your leader in particular? Felicia. What's the topic? Water train. Raining water. Raining, yeah, yeah, yeah. So what's to do with raining water? Oh, is it a textbook question? It's a textbook question. Okay, okay, okay. Sure. Raining water. Raining water. Which topic is that? Which number? Yeah. Okay. Gopagani. Yep. Gopagani. Group 10. Group 10, I think already got football. Okay. Arthur. Is Arthur here now? 18. Okay. Thank you. Arthur not here. Jose. Hisham. Right. Daniel. Got. Hashim. Hashim here. Okay. Newton's law. Who's your leader? You? Are you a leader? What? Okay, you. Hashim. Okay. Maybe I will contact the leader later, especially for submission. Madia. Yeah. Madia. Yeah, who's the group leader for Madia? You are okay, correct. Aaron, Aaron got coffee already water. Okay. Brandon got Gunakanti. Yeah. And then Margaret, Javed, Javed here, right? Javed. Gabriel here, not here. Jeffrey here. Okay. Purity. Okay. So if I release you earlier today, please use your time to discuss with your friends. You can stay back and discuss for the presentation. You can stay back. Okay. Deal? Okay, you can step back. You can use this room to discuss because no one gonna use this room except you. 然后用 latex 打出来。Yeah, yeah, that's it. 还是你要自己画，然后你自己找你自己。Yeah. Okay. So do you guys know how to make a PPT using mathematic equation? You guys know? You can go to this place here. Yeah, you can go to this place. Well, I mean, like you can learn to use this. I think you are CST, right? You are Very familiar with coding, right? This code is very easy. You should be familiar. Overleaf, you can use overleaf. Or no need, no need, no need, no need. I mean like no need, no need, no need, no need. Is available. Is the template is available. So you search overleaf beamer. Okay, you use this beamer here. There are templates here. You can just use it. Yeah, use this. Okay. Let me see. It will look something like this. Okay, so why we like to use latex, because the equation will look nicer than you use Microsoft Word. Okay, because Microsoft Word you need to find the symbols, you need to adjust it. But if you use latex, right, it will adjust for you. Okay. So let me show you the template. You don't need to start from scratch. Okay. You have template. You see, there's a lot of template here. Okay. So let me show you the template. I guess the template is here. Latex template. Okay. So you use this, download and then use. Overleaf is free one. So 厦门大学 again. You can try. There's a lot of nice, even nicer one. You don't need to use 厦门大学. You use a nicer one. Yeah. Yeah. Okay. Yeah, you can try and download this and then use. Okay, it's very easy. No need to start from scratch. You use the template. Okay, lecture the Beamer template. But maybe some of the symbols you need to learn. What's the name for those symbols? Yeah. Other than that, should be easy for you. Okay, the template is available. So this overleaf is free, but if you want to share among your group mates, right? Maybe I think at most one only. Uh, I mean, meaning if you want to have 3 or 4 people to access to the same thing and edit together, then maybe at most one. Maybe only 2 of you can do it together. Or you create an account that everyone can use it. Depends on how you want to do it. Or you make your own template and then combine together also can. Yeah. Because you have separate parts, right? Everyone will talk about different part of your thing. Okay, yeah. Go and download this and use. Should be easy. Beamer, remember the name, Beamer, Overleaf Beamer. Okay. If you really don't know, you can just look up some tutorial. It's very easy to start. But maybe some of the symbol you need to familiarize. For example, like begin the theorem or begin equation, something. Mm. Other than that, you can start playing with the template first. Playing with this template. Okay. Playing with this template. The advantage of using Beamer than your Microsoft PPT is the Beamer will arrange the equation better than the PPT and more efficient. If you use Microsoft, the experience is if you put too much graphic or too much equation, you're stuck, you're lag. But Beamer won't, because it's special made for those symbols. Okay, seems like everyone is ready, huh? Do we do quiz 3 and then we can call it a day? Okay, I have returned you the quiz 3. Please open up and have a look. If you think that we mismark you, then you can let me know. Okay, so for the first question, I think we did it in the lecture before, but few of you say that this is a Leibniz what rules? Leibniz derivative rule or something like that. Okay. So where did you find that term? Anyone of you? Huh? Where did you find that term? Sorry? Ah, ah, Google, huh? Okay, I also expect that. Maybe you found Google or you ask ChatGPT. But it's the same thing that we did in class actually. Okay, how to derive that formula is using chain rule. Okay, so you need to realize that. Um, I think there's only, I think there are two of you at least realize that the integral is a function of fx. Okay, so we can rewrite this become d of fx over d of d of fx cube over dx cube and then dx cube over dx. So this is a chain rule. Okay, so you need to write down this step here. And then we also take marks if you don't know how to split out the function. Okay, if you don't know how to split out the function, we also take it out. Because you know where you guys split? Some of you split at 0. 0 doesn't make sense, or why? Because square root 0 minus 2 is what? Square root minus 2 is complex. It's not defined on the real. Okay, so you need to split at some value that makes sense. For example, 2 will make sense. And then 3 also makes sense, 4 also makes sense. Okay, as long as you split at the place that this function could define, that would be okay. Yeah. Any question? Looking at your mistake, is it clear why you are deducted mark? Is it clear? Okay. I'm going to warn you. This question definitely will come out in the exam again. So make sure you understand it. Really. Okay, make sure you understand it. Otherwise, you're going to lose mark again. Okay, this will definitely come out in the exam. Okay, make sure you understand what's going on here. Okay, you need to use chain rule. You need to use fundamental theorem of calculus. Okay. Okay. So the thing that you need to notice here is you cannot just straight away substitute your s cube inside your final answer because you're gonna miss your derivative. Okay, so why the derivative appear is because of the chain rule. This is what you call the Leibniz. What's the name you called it? What's the name you called it? What's the name that you say the formula, the Leibniz formula? A lot of you use that formula. Any one of you use the formula without showing the chain rule? I think a few of you use it. What's the name? You guys use it? The first. Yeah, you are using the first fundamental, but they are no. They just go straight to the last line. There's a formula. Exactly because of this, but they use formula. There's a name for it. Leibniz something formula. What? Did you use it? Yeah. That's why. How? You need to derive this. You need to derive it. Okay, you need to derive it. Or let me check. I think. Yeah, let me see. Think Leibniz integral rule. Anyone use that? Leibniz integral rule. So they just straight jump straight to the last line. Leibniz integral rule. So why the Leibniz integral rule works is because of the chain rule, because of the fundamental theorem of calculus. Okay, no? Yeah. So you need to do it step by step. Okay, so far, any more questions? for question 1? Any more question? No? Okay. I think question 2, is it tricky? Not as tricky, but some of you got tricked. For example, 2A. Again, you go into some very tedious calculation. But in fact, if you turn the power into power, I mean, in particular, the square root into the powers, then you can just see that you are just adding. You could just adding 1 to your power and then divided by the new power. Then you get the solution already. And I think one of the tricky part is this is integrating from 4 to 0. Usually we'll go from 0 to 4. So that's why you can expect a negative popping up here. But actually it still depends on the integral. Okay, and then the second one maybe it's harder because it's about trigger function here. But I guess most of you realize that you just set your u to be substitution here. What's your substitution? You're gonna do u equals to 2 plus secant 3x, is it? Okay, you realize that this will work. Correct. Because just now we said that derivative of secant x is secant x times tangent x. Okay. There's one thing I want to remind you is after you do substitution, right? Make sure you change your integration limit as well. Some of you just use the same one. Then wrong. Or you change one of them but didn't change the other. Kind of weird. You forgot. Okay. Yeah. Okay, so please make sure that you make the correct change. So for example, x is pi over 9, x is equal to pi over 12. So what are they in terms of u? Okay, you need to compute. Okay, I think that's the thing you goes wrong for this part. Okay, for the last part, I'm surprised no one draw the picture, but you know how to calculate. This is very dangerous, because it's kind of like guessing. Okay, make sure you know how to draw the graph. Usually we can give you a question that you can draw the graph. Okay, so let's look at this question more details. So you have a region in the xy plane bounded by a parabola and a straight line 2x minus 4. Okay, so basically this is the red line here. Okay, so maybe I should draw it again. Okay, like that. Okay, so to find the intersection point, I think it's easy. You all know how to do it, just make them equal. But to find the area bounded by this region here, it's not too hard. It's not too hard. So how do we do this? So if you realize if you do in the x direction, right, it will be splitting into the positive part and negative part. So I think none of you did this, so which is a good point. So what you do is you do in the y direction. Okay, so you take the top part minus the bottom part, you left with the middle part. Okay, this is what this area is doing. Okay, or because now you got more time, right? Maybe I can challenge you, try and do the x direction. So take this top part here, minus this bottom part, and then compute this bottom part as well. Okay, you can try and do this direction, see you get the same answer 9 or not. Okay, to train that you can do in a different way. Okay, second is cylinder. How should you think about this cylinder actually? So okay, so before that, you want to find a volume of solid. You see, this is solid. Just now what we learned was surface. Now it's solid. Okay, solid generated by revolving the region D around the horizontal line y equals to -2. Okay, y equals to -2 is here. So you find the intersection. One of them is at y equals to -2. So you revolve this. Okay, so the question asks you to use cylinder. cylindrical shell. So suggest you to use cylindrical shell. So to use cylindrical shell, right, you need to draw your cylinder first. Okay, so how does this cylinder looks like? How does this cylinder looks like actually? So let me draw the other side of your thing like that. Okay. So what's your cylinder looks like? So your cylinder like must look like something like this. Okay. Okay. But if you go for different Y, right, you can see that your cylinder, the bottom part is controlled by one curve, the top part is controlled by the other curve. Can you see or not? Can you see? Can you see that the here is the bottom, here's the height, here's the top. Okay. So the top of your cylinder is controlled by the linear line, and then the bottom of your cylinder is controlled by the parabola line. Okay, so that's why in this formula here, you are taking the linear line minus the parabola line. Okay. How about radius? How about radius here? Why is it y plus 2? Why is it y plus 2 here? Okay, so basically you should count from this y equals to minus 2 line. Okay, you should count from y equals to minus 2 line. So if you're at minus 2, your radius should be 0. Okay, so that's why you plus 2. Right, should be 0. And then when you add, for example, 4, how far are you from minus 2? Is 6. So that's why you plus 2. Okay, so that's why this become a y plus 2 for your radius. Does it make sense? Okay. Yeah, because you count from minus 2, instead you count from 0. Usually revolve around x-axis or y-axis, right? So if you revolve around x-axis, your 0 count from y equals 0. Okay, but now your 0 count from y equals to minus 2. So that's why you have a plus 2. Okay. It's very dangerous. You don't draw, but you know how to calculate. If I change the question a bit, then you must be wrong. Okay, so make sure you know how to draw and then what are these number are doing. Okay, why you take the linear line with the difference of the parabola line. Okay, this is something that you need to check. Okay, yeah. Because this question is easier, you can just guess what is happening. But when the question get more complicated, you don't draw, you don't see what is going on, it's very easy to get wrong. Luckily, no one of you like swap the order of this difference. Otherwise, you are really just guessing. Or you did try and then get negative, so you don't want it. I don't know. I just guess. Yeah. Once you get these, I think the calculation below is just integration for polynomials. So it should be. Okay. Any questions so far? Any question up to here? Any question? Question? Okay. If no question, let me fix settle this first. So I want a group leader from group 6, Le Tian. Le Tian. Are we done with this? Le Tian. And then group 6 got who? Le Tian, Rui Yan. And then who else? Tommy. Oh, we fixed already. It's Desmond, is it? Okay, good. Very good. Okay. So any more questions? Do you want to go into differential equation this week or next week? Next week? You want this week? One of you want this week. How about the rest? You want to continue with differential equation or you want to start differential equation next week? Okay, maybe we vote. So who wants to start differential equation this week? Today? No one. Who wants to start next week? Next week. Hey, next week also no one, or then we cannot decide. Huh? What do you mean give up? Doesn't teach, but it will come out in your exam. Okay, we start next week. So if you like, you can stay back, or you want to ask question, maybe I can stay a little while. If not, you can discuss your group presentation now. Actually, yeah, spend your time discuss your presentation. Okay, yeah. I will step back a little bit if you have question. Okay. Otherwise, you can spend the time now discuss your project with your friends. Yeah. 你只要确保你说的清楚，确保这每个人3个包。Okay, you should time yourself and make sure each of you is 3 minutes. But if you are individual, you have to make to 5 minutes. 看得懂什么意思？没有啊，你一定要讲到我明白嘛，对不对？你不能够说我明白，然后你乱讲，没有这种事情嘛，对不对？OK，你要把单纯不明白，好不好？当白痴，你要把一个白痴讲的会。Okay, we assume that we learn differentiation, we learn integration before. Okay, this is what we assume. Okay, you should assume. Okay, this is a very good question. So how do you assume your audience? You should assume that your audience is like your classmate. You learn derivative already, you learn integration already. Okay, then you need to tell your classmate how we apply this to different places. Okay, yeah. Yeah. Yeah, so I think 3 minutes is pretty long. So just speak slowly, speak clearly. Not very long, you try already. Because what happens in my MAT class is I give them 1 minute. I give them 1 minute, huh? Because I don't want them to like speak like rubbish. Usually people like just simply say things. I want very a very focused content. I don't want them to like speak rubbish. Okay, so 3 minutes is kind of long. I mean, depend on your content. I think your content is not very long as well because you are split among us, right? So make sure you clearly. Okay, speak clearly. That's the thing. Okay, speak clearly. So try and practice few times, record few times. I mean, before recording, you should talk. You should present to each other. You know, I present to you, you present to me. Hey, this part not clear. I think this part not clear. You should add this. This part not clear. You should add that. Okay, this is how it works. Okay, you present to your group mates, and then only your group mate understand you. Only your classmate can understand you. Only I can understand you. Okay, otherwise you are just talking to yourself. Okay, you have presentation in different classes or not? What class? Linear algebra got no. Got it? Linear algebra got project? What? What project is that? Got presentation. Yes. See. But what kind of presentation they give? What is the topic? Also application.
Yeah.
Oh, okay, okay, interesting. Okay. How many units are 3 units? Three. Is it 3 units? How many hours you have
Hours.
each week? 3 week, 3 hours. 3 hours.
Yeah.
Oh, surprising. 3 hours also for project. I thought only for 5 hours. Oh. Okay. Linear algebra. How about the rest? Your computer science also got presentation.
Yeah.
Recording or face to face?
Face to
Face
face.
to face. Okay. Individual of the how many in a group? 8. 5. Also many. 6. Also a lot. So how many what's the duration you need to present?
Each person 3 minutes.
Also 3 minutes. Okay. Standard. Kind of standard. How you guys do in different courses? The midterm. Okay or not? Not very good. Can still got room of improvement. Yeah, I mean there are like 3 years to go, right? 3, 4 years. Yeah, you can try and get better. Another problem is maybe you come out from the home, right? Out of home, so you also need to familiarize with the environment. So the highest score we got for midterm is 99. Yeah, 99.
我忘掉了，忘了我写什么了。这样吧。哎，
I think you guys can do better, I guess. Yeah, you guys can do better. Definitely. Seeing from the quiz result, you can do better. Hopefully, final can be even better. Yeah, please spend time to do revision. If you notice, right, when we go along the chapter, right, the chapter will get simpler and simpler. We just ask you to compute some very obvious thing. So I guess mostly this class will focus on techniques. Focus on techniques. In particular, those trig substitution, bypass, those try to be familiar. Right? At least the one in the lecture you should know. Lecture. We won't give too how to say too tricky questions. Okay, at least the lecture one you need to understand very well. Okay. Other than that, do you find this degree hard or not? No, not hard. Maria said not hard. Easy. Piece of cake. Yeah, it's so hard. Okay, some of you so hard. Yeah. Okay, so you need to arrange your time wisely. Yeah.
在想怎么怎么样，这里经济的受理是为影响方面，心情很大。
可以参考一些。
我知道我会，但是我知道我不知道怎么想。他会，他不会，
他会 contradiction. Yeah, you can spend time discuss with friends here. or you can ask me question. Huh? 诶，你要说吗？Hey, hi, after we have finished class. Finish. We're finished. We'll continue differential equation next week. Yeah, we finished chapter 8. We finished quiz 3 discussion. Okay.
是什么？知道。我也不知道。
Yes. You haven't called your name? Yeah. I think I took your attendance, right? Because you are free. Huh? Yeah, I know. You should assume.
Teacher, my attendance.
Sorry?
My attendance.
But you are late. Why? You are late.
Please.
But no, please, because you are breaking the rules. How to please? You know you are breaking the rules? Yeah. So yeah. Yeah. I took for you. Anyway. Yeah, I took for you.
My name is Gunagati Sali.
Sorry?
Gunagati Sali.
Gunat. Yeah.
How much we are?
How much? Yeah, sure. Point. Yeah, right. Sorry.
我要考那个 group 是多少？
group 19。OK。我看一下。
下次我们就开上 chapter 9。
对。
chapter 8后面那个上。
那个 physics 好了。对。
我可以看我的 group 几。
可以。
group what？
你既然这个周末写完，
哦，对，那个，
我不知道我为什么要写。
就是我帮你改。
快。谁？哦。
看。
Okay, thank you.
OK, thank you. Bye bye.
你好啊。
下一组。嘿，这
跟那个
啊，你不是迟到吗？
哦，
我没有叫你啊。
对，那可以把这个
迟到了
没关系是
，absent 对啊，
你知道是 absent。
当然了。
哦，那会有影响？
应该不会吧？不确定。
有意思。好的。
对呀。
好像有点多次，我以为今天迟到之后都会多。
I mean like 我只是
OK。
呀。
OK。
也是那个很难的题
啊，怎么样？
你每个换元都是算出来的这个玩意儿和之前那个答不一样啊。
不可能啊！像你那个电脑算的不是就是一样的东西吗？
不可能你打错了吗？那我这个是
啊，你打错了，是1/4x。喂，不是喂，等一下，你打的是哪个？我们有好几个版本的，其实
是那个
我知道，我就说了，我们有好几个版本呢，有好几个算法，你是在算着哪一个？
这个呀。但是看着觉得不太对呀、
不可能啊！我刚才用那个计算机算了，不是一样吗？
那怎么直接输进去，怎么会变成1.几和5.9呢？它又不是2倍或者不
你有算错了？
没有？
没有，你少了，你少了，你看，
哎，不是，还有个1/4吗？
没有啊？对，除四就是这个答案。
哎，
嗯，OK，
你这个东西为什么可以从4往0积分呢？为什么可以从反方向积分呢？为什么感觉它有点不定义啊？
有负定义不定义，因为反方向的话就是有一个负，就是记得吗？A
就
B
前面有个符号嘛。
啊，对，没有错。
是啊，结果上就多一个符号。结果我留了一手，不然要被扣分的。我是当0到4算的，然后我告诉你，如果它是4到0的话，应该是负的。结果留了一手，不然要被扣分的。对，然后老师请教你一下，那个 Teams 怎么给自己录视频、录屏？我自己开录视，我自己在电脑上开会议，他不让我开呀。
多不可能，
就他是这样子，waiting for others to join，然后什么都不让我用，然后什么东西
哦，
你
你
也不让我用，屏幕共享也不让我用，我录个蛋。
我等一下啊，我示范给你看。
所以
没有你